Let's explore what makes a square special. This shape is one of the building blocks of geometry that we use every day, from tiles on a floor to the shape of paper. A square has 4 sides that all have exactly the same length. Mathematicians often use a single letter to represent this length. We'll use the letter A to label each side. Unlike rectangles, where opposite sides can be different lengths, a square is special because all 4 sides must be exactly the same length. If we measure any side of a square, all other sides will have that same measurement. Squares also have 4 perfect right angles. Each corner makes exactly 90 degrees. This is why squares fit so perfectly when we tile them together, like on a chessboard or kitchen floor. When we put all these properties together, we get a perfect square. These 2 features, equal sides and right angles, are what make squares so useful in mathematics and in the real world. These special properties of a square will help us understand how to find its area. When we know the length of just one side, we can calculate how much space the entire square covers, which is exactly what area measures. Area is a fundamental concept in mathematics that measures how much space a shape covers on a flat surface. When we look at different objects, area helps us compare how much space each one takes up. Let's explore some common shapes we see in everyday life and think about the space they occupy. Here's a square. Notice how it has equal sides on all 4 sides. And here's a circle, which is a set of points that are all the same distance from the center. This triangle has 3 sides and 3 angles. And finally, a rectangle has 2 pairs of equal sides, like a stretched square. Each of these shapes covers a different amount of space, and we need a way to measure and compare them. To measure area, we use what we call square units. Think of it like covering a floor with identical square tiles. We would count how many tiles we need to cover the entire floor. Let's focus on our blue square and see how we can find its area. We can divide it into smaller, equal-sized squares. Each of these smaller squares is exactly 1 unit on each side, and we call this a square unit. If we count, we can see our blue square contains 4 of these square units. This 1 square unit becomes our measuring tool for area. Just like we use inches or centimeters to measure length, we use square units to measure area. It's our standard building block. Mathematicians have found special formulas to calculate the area of different shapes without having to count all the square units one by one. Each shape has its own unique formula. For our blue square, the formula is A equals S squared, where S is the side length. Since our square has sides of 2 units, we calculate 2 squared, which is 2 times 2, giving us exactly 4 square units. This matches what we found by counting the unit squares. We use area measurements every day, from calculating how much paint we need for a wall, to determining how much carpet to buy for a room, to understanding the size of a playground. These concepts will help you solve more complex problems as you continue learning mathematics. Let's explore how to calculate the area of a square by thinking about how much space it takes up. To measure the area of this square, we need to figure out how many unit squares can fit inside it. Each unit square takes up exactly 1 square unit of space. Now let's count each unit square one by one to find the total area. Each unit square represents exactly 1 square unit of area. So our square has a total of 9 unit squares inside it. Looking at our original square, we can see it has 3 rows and 3 columns of these unit squares. Instead of saying 3 rows times 3 columns, we can simply say 3 times 3, which gives us 9 square units. Another way to write 3 times 3 is 3 squared, which is the same as 9. Now let's see if we can find a pattern that works for any square, not just this 3 by 3 example. Let's consider a square with any side length. We'll call this side length A to represent any number. If we think about filling this square with unit squares, we would have A rows with A unit squares in each row. That gives us a total of A times A unit squares. Just like we saw with our 3 by 3 square, the multiplication a times a can be written more simply as a squared. This formula works for any square. If a square has sides of length 4, its area would be 4 squared, which equals 16 square units. If its sides are 5 units long, the area would be 5 squared, or 25 square units. The beautiful pattern here is that the area of a square is always equal to its side length multiplied by itself, or in other words, the side length squared. Let's explore how the area of a square relates to its side length. When we talk about area, we're measuring how much space is inside a shape. Here's our first square with a side length of 2 units. Each side is exactly 2 units long. Let's divide this square into smaller squares that are exactly 1 unit on each side. These are called unit squares. Each unit square has an area of 1 square unit. We can count that our 2-unit square contains exactly 4 unit squares. So the area of this square is 2 squared, or 2 times 2, which equals 4 square units. We can think of this as having 2 rows with 2 unit squares in each row. Now let's look at a larger square with a side length of 4 units. This square is bigger because each side is 4 units long instead of 2. When we divide this square into unit squares, we can see it contains 16 of them. That's because we have 4 rows with 4 unit squares in each row. The area of this square is 4 squared, or 4 times 4, which equals 16 square units. We multiply the side length by itself because we need to count all the unit squares inside. Here's something interesting. When we double the side length from 2 to 4, watch what happens to the area. We're making the sides twice as long. The area doesn't just double, it actually quadruples. It becomes 4 times larger, growing from 4 square units to 16 square units. This happens because we're adding more unit squares in both directions. We get more rows and more squares in each row. Let's try one more example with a square that has a side length of 5 units. This will help us confirm the pattern we're seeing. When we divide this 5 by 5 square into unit squares, we can count a total of 25 unit squares inside. We have 5 rows with 5 unit squares in each row. The area of this square is 5 squared, or 5 times 5, which equals 25 square units. Again, we're multiplying the side length by itself to find how many unit squares fit inside. Looking at all 3 examples, we can see a clear pattern. For a square with sides of 2 units, the area is 4 square units. For a square with sides of 4 units, the area is 16 square units. And for a square with sides of 5 units, the area is 25 square units. In each case, we're finding the side length squared. This gives us the formula for the area of any square. Area equals side length squared. This works for any square, no matter how big or small it is. If you know the side length, just multiply it by itself to find the area. Now let's see how the area formula for a square helps us solve practical problems, like calculating how many floor tiles we need and how much they'll cost. Here we have a square floor that measures 6 meters on each side. Notice how all 4 sides are equal, which is what makes it a square. To find the area of this square floor, we use the formula, area equals side length squared. For our 6-meter square, we calculate 6 squared, which equals 36 square meters. But what does 36 square meters actually look like? Let's visualize this by dividing our floor into 1 square meter tiles. By drawing these lines, we've divided our square floor into smaller unit squares. Each small square represents exactly 1 square meter of area. This yellow square here is 1 square meter. It's our unit for measuring the floor space. Now, let's count how many of these 1 square meter tiles we need to cover the entire floor. Let's start counting in the top left corner, 1, 2, 3, and so on. If we continue counting all the tiles in our 6 by 6 square, we'll count exactly 36 tiles. This matches our calculation of 6 squared equals 36 square meters. This shows us why the area formula works. We're literally counting how many unit squares fit inside our shape. Now let's take this a step further. Imagine each floor tile costs $5. How much would it cost to tile the entire floor? To find the total cost, we multiply the number of tiles by the cost per tile. Since each tile costs $5, we'll multiply 36 tiles by $5. So for our 6 meter by 6 meter floor, we need 36 tiles at a total cost of $180. This is a perfect example of how the area formula helps us solve real-world problems. Understanding the area formula allows us to plan projects, estimate materials, and calculate costs in many situations, from tiling floors to painting walls. The area of a square is one of the simplest formulas in geometry that you'll learn in middle school. In this formula, A represents the total area of the square, while A represents the length of just one side. This is read as area equals side length squared. What makes this formula so useful is that it works for any square, no matter how big or small. You just need to know one measurement, the side length, and you can find the area by multiplying that number by itself. Squares are everywhere around us. Let's explore 4 common examples where we can apply our area formula in everyday life. First, let's look at a chessboard. A standard chessboard is a perfect square with 8 small squares on each side, making 64 squares total. If each side of the board measures 8 inches, we can find its area. Next, city blocks in many places like New York or Chicago follow grid patterns and are often square-shaped. If a city block is 100 meters on each side, we calculate its area by squaring 100. Many windows in homes and buildings are square-shaped. For a window that's 1.5 meters on each side, we can find the area by multiplying 1.5 by itself. This tells us how much glass is needed to make the window. Floor tiles are often square-shaped too. If a single floor tile has a side length of 30 centimeters or 0.3 meters, we can find its area by calculating 0.3 squared. This helps contractors determine how many tiles are needed to cover a room. Let's take a look at all these real-world examples together. Notice how, despite their different sizes, we use the same formula to find the area of each square. For all of these examples, we follow the same pattern. Take the side length, multiply it by itself, and we get the area. The chessboard with 8-inch sides has an area of 64 square inches. The city block measures 10,000 square meters. The window is 2.25 square meters, and each floor tile covers 0.09 square meters. This formula is used every day by architects, designers, construction workers, and even game creators. Knowing how to calculate the area of a square helps us measure space, determine materials needed, and solve many practical problems. So whenever you see a square shape, remember that its area can always be found by taking the side length and multiplying it by itself, or in mathematical terms, squaring the side length.